Hey, it's Mr. Kingsbury. Today I'd like to talk to you about transformations on square root and cube root functions. That's our topic for today. We're in the radicals unit in Algebra 2. Here are our two essential questions. First, how do I identify the transformations to the square root and cube root parent functions given an equation? Second, how do I write the equation of a square root or cube root function given the transformations applied to the parent function? So we're going to be doing transformations two different ways. And truthfully, at this point, you have seen transformations on absolute value, on quadratic, on cubic. And I feel like there's one more, but it escapes me at the moment. At any rate, you've seen it a number of times. So none of what I'm about to show you should be a huge surprise. First of all, before we can talk about answering these questions, I need to remind you of a few things. So first of all, the square root, transformation equation looks like this. Looks like this. Y equals A times the square root of x minus c plus d. The cube root transformation equation looks like this. This is a lot to write. Y equals A times the cube root of x minus c plus d. You'll note the only difference between the two is that one has a 3 in the crook there. The second one, the cube root, has a 3 there. That 3 tells me the difference between the square root and the cube root. You can write roots all over the place. You can put any root that you want here. This one is a cube root. The other thing I wanted to remind you is that is what each of these things stands for. So A controls vertical stretch and compression, right? So for A, right, the value vertically stretches or compresses. Right? Stretches if the A value is bigger than 1. Compresses, that's an S, if the A value is between 0 and 1. Ignore the sign. The sign is something else. In fact, this sign reflects this thing, reflects the graph over the x-axis. Specifically, that's the negative sign. So a negative A, it's reflected. A positive A, it stays where it's at. The C value moves the graph left or right. Left is if it's a negative, right is if it's a positive value. And a note, okay? Note, the C value's sign changes. When you take it from the equation. Please note there's a negative in front of each of these C's in the equations. So if it looks like it's a negative C value, then in reality it's a positive C value. You have to adjust for that negative there. Okay, and then lastly we have the simplest of these, which is the D value. This moves the graph up and down. Up is plus, down is minus. So let's take a look at a few of these. Let's look at a couple examples here. and I should make a note. So I went back here so I can make a note. The best way to complete these problems is to identify the A, C, and D values first. And what I'll do is I'm going to do 4 examples, okay? So you can see 2 of each type of problem and 1 of each of those with each of our 2 types of functions. So for example, let's say I give you y equals 4 times the square root of x minus 7 plus 1. And I want to know what are the transformations. First of all, I would identify A, C, and D. This is your A, this is your C, this is your D. So A is 4. C looks like it's negative 7, doesn't it? But it's not. Remember, we have to adjust for this. This is an extra negative we need to get rid of. So in reality, it's not negative 7. It's positive 7. And then right here, our D value is positive 1. Now we can interpret them. So when I look at A, I'm going to look at 2 different things. What is its sign and what is the value, right? So the sign is positive, which means there's no reflection. So I don't have to worry about that. The value is 4. 4 is larger than 1. That makes this a vertical stretch of 4. And I need all of those words. You can't just tell me it's a vertical of 4. That doesn't even make sense. You can't just tell me it's a vertical stretch because I need to know by how much. And you can't just tell me it's a stretch of 4 because I need to know, am I stretching vertically or horizontally? I need all of these pieces. Next up, we have our C value. Remember, C controls left and right. Left is negative, right is positive. This is a positive 7. Positive is right. So instead of positive 7, I'm going to rewrite this as right 7. And then lastly, we have our D value, which controls up and down. Positive is up, negative is down. We have a positive 1. So positive is up. So I'll rewrite this instead of plus 1, I'll write it as up 1. So we have a vertical stretch of 4. It's being moved right 7 and being moved up 1. See? Pretty easy peasy. Let's do another one. How about we got y equals negative 2/3 times the cube root of x plus 1 minus 5. Of course I would break my lid. Again, let's identify our A, our C, and our D. And I really wish I'd given myself more space. But here we go. There's the A, there's C, and there's D. So negative 2/3. C looks like it would be positive 1, doesn't it? But remember, we have to adjust the sign. When the C value gets pulled out of the equation, the sign changes. So this is actually negative 1. And then our D value is negative 5. Now let's interpret them. The sign of A is negative. That means a reflection over the x-axis. The value of A is 2/3. That's less than 1. So that's going to be a vertical compression by 2/3. And please do not get in the habit of assuming that if it's a fraction, it must be a compression. Fractions can be bigger than 1. 100/3 is a fraction, and it is definitely bigger than 1. So fraction does not necessarily mean compression. You have to look at its value. In this case, 2/3 is 0.66666 repeating. That's less than 1. So we got a vertical compression by 2/3. Now let's look at our C value here. We've got a -1. Remember, C controls left and right. It moves the graph left and right. Left is negative, right is positive. We have a -1. Negative is left, and it's 1 unit. So this will move left 1 unit. Lastly, we've got D, which controls up and down. Up is positive, down is negative. We have a -5. So negative would be down. So this is down 5. Okay. So what went on here? Well, there was a reflection over the x-axis, a vertical compression by 2/3. It moved left 1 and down 5. That's all there is to it. Now let's go the other way. Example 3. Let's say that I told you that something moved up 4, left 2, and was vertically stretched by 5. Sounds good. I still want you to find the A, the C, and the D. So up 4, up is D. D is up and down, right? Positive is up, negative is down. This says up 4. Up is positive, so this would be a +4. Left 2, that's my C value. C controls left and right. Left is negative, right is positive. This is a left 2. Left is negative, so I'm going to put -2. And then vertically stretched by 5 is my A value. Because there's no reflection, it's not negative, it stays positive. Then all I have to do is write the equation, okay? And let's say that we're going to do on this one, let's say that it's the square root. What you'll be given will be much more complete. It will say, what would be the equation of the square root function, or what would be the equation that resulted in the square root parent function being moved up 4, left 2, and vertically stretched by 5. So you would start by writing this. Remember this? A times the square root of x minus c plus d. And then you plug in for A, C, and D. So my A is 5. My C is -2. And my D is +4. And the only other thing I need to do is right here where I have the double negative. Instead of 2 negatives, make it 1 positive because 2 negatives make a positive. So I get y equals 5 times the square root of x plus 2 plus 4. Let me do one more and we'll call it a day. So example 4, let's say that the cube root function, parent function, was moved, let's say it was moved down 5, right 6, was reflected over the x-axis, and vertically compressed by 1/2. Once again, I'm going to suggest you identify A, C, and D. Let's go through. So down 5. Down is D. D controls up and down. Whoops. D controls up and down. Up is positive, down is negative. We're going down 5. So down would be negative. That makes down 5 a -5. Then we're moving to the right 6. C controls left and right. Left is negative, right is positive. We're going to the right 6. So that would be +6. Then it says reflection over the x-axis. That's one part of the A value is a reflection. That makes it negative. And then it says vertical compression by 1/2. That's the other part is 1/2. Now we're using the cube root function. So that would be y equals a times the cube root. Of course I would break my pencil. Cube root of x minus c, and I need a little 3 here so I know it's a cube root, plus d. Please remember this 3 is not a transformation. Ignore it. It's just there to tell us that this is the cube root. Then we plug everything in. So for a, I will put in negative 1/2. Then we have our cube root sign. X minus c is 6. Now, I could put in, I mean, if you really want, I can. You don't need to do this. I'm kind of streamlining it, but I put a plus in front of the 6 just so that I would know. I mean, if you want, you can put plus 6 like that. And then the d value is negative 5. And if you want, you can then go and adjust, because we really don't put minus a positive. We just put minus. So we end up getting y equals negative 1/2 times the cube root of x minus 6 minus 5. And that's transformations, ladies and gentlemen. I hope that's been helpful and instructive, and have a great day. Bye.